Hello, Dr. Kernighan, and welcome to Computer Science Chats. How are you?
I am absolutely fine, Victor. It's a pleasure to be with you this afternoon. It's cold here in Princeton. I assume it's cold where you are, but nice. The sun is shining and everything, so it's a good day.
Yeah, it's a pleasure to meet you as well. So, I've prepared several questions to ask you. And first, could you please introduce yourself and your educational and career background?
Yeah, sure. My name is Brian Kernighan, and I'm used to all pronunciations, so don't worry about any aspect of that. I actually grew up in Canada and went to undergraduate at the University of Toronto. I came to Princeton for graduate school a long time ago. And after I finished graduate school, I worked at Bell Labs for 30 odd years. And then I came back to Princeton to teach in the computer science department, where I've been for the last 20 plus years or something like that. So there's the capsule summary of not having moved very much at all.
Thank you. So, what is it that originally inspired you to pursue computer science as a career?
Well, when I was your age, let's say, there was no such thing. Just because this predates computers, at least in the sense that we see them today, where everybody has a bunch of them. This would be back in, well, let's call it when I went to college in 1960. Uh, there was kind of only one computer at the whole university. By the standards of the time, it was a big computer, but by today's standards, it would be physically big, but in terms of power, almost negligible. Um, and I didn't even encounter that until I was well into undergraduate time. But I had a job partway through an internship where I saw computers and they were sort of interesting. And I think sort of in my last year of university, undergraduate, I decided that, computing looks like it's sort of interesting, but I sure didn't know very much about it. So I got more into it as a graduate student, where this was before computer science departments in universities as well. So I was actually in the electrical engineering department, but there were people there who were interested in computing. Um, and so I took some courses in computing, and I got lucky and got some summer internships, which really involved computing that was kind of on the edge, modern, leading edge of technology. And that kind of solidified my interest, I think, because it was good. I mean, everybody gets lucky once in a while with their internships, and I got 2 or 3 in a row that were great. So
Yeah, that's very interesting. So, could you describe some of the activities that you do through your work?
yeah, so I was at Bell Labs. I was doing research for 30 years, basically trying to do new things with computers. Since I come to Princeton, much more of my time has been spent on teaching. I teach a couple of courses uh, every year, and their undergraduate courses. And one of them is specifically aimed at people who are not actually computer science majors, it's aimed at people who are in the, I'll call it humanities fundamentally. The average person in the class is an English major or history major or something like that. So I do that. I work on books and so on. And there's a fair amount of what you would call administration or dealing with bureaucracy and so on, some of which is actually fun and interesting, and some of which is just a chore. But that's a story of life for lots of people, so it's not a big deal.
Yeah, thank you. So, what do you like most and what do you find most challenging about these activities?
Well, I think the teaching part is fun. I mentioned this course that I've been teaching for people who are not very technical and trying to explain what computing is about, how the internet works, how to be careful with your phone, all these kind of things that you will know. And I suspect many of the people listening to this will know. But lots of folks don't know that. And trying to explain it at the right level, get enough detail that people can sort of see what's going on, but not bury them, try and convey things that will still be true in 10 or 20 years, as opposed to whatever's fashionable today. So all of that kind of thing I find rather rewarding, and certainly it's fun to hang out with these folks who are, because of their interests, they're just in a population that I might not otherwise encounter. And so I find that intriguing as well. So that's the fun part. The challenging part is to try and actually teach people. Um, And I'm sensitive to this at this point because I just finished grading the midterm exam for the class, and that's always, I'm sure you've been on the other end of this kind of thing. Um, and it's always one of those things where you think, oh, geez, why don't they get it? And of course, if everybody doesn't get it, that says I screwed up. It's not them, it's me. I got to figure out a better way to explain how things work in a way that they can grok. So anyway, the good bit, the bad, but a lot of it focuses around the teaching.
Yeah, so I've read, and I know you just mentioned that you worked at Bell Labs for a while. What was that experience like, and how did it like influence your more current work?
So it was an enormous amount of fun. And so let me insert a commercial announcement here. Several years ago, on basically the 50th anniversary of Unix, I wrote a book that was sort of a history of Unix in those early days and a bit of the personal memoir stuff. And so go buy it on Amazon. Okay, end of commercial announcement. But a lot of what was in that book was to talk about what was the really the fun parts of working at Bell Labs. It was it was a really good environment for doing research. It was early days in computing, so there was a lot of what the cliche is low hanging fruit, things that were today would seem really obvious and easy, but at the time were not so easy. So lots of interesting things to work on, particularly because Bell Labs was part of AT&T, and at the time AT&T provided telephone service for an awful lot of the United States, and so that meant that almost anything that you might be interested in as a sort of computer related thing might help with some problem that AT&T had because it was such a big operation. It had so many technical things to deal with in running, managing, and improving an enormous telephone system. So that was fun. Great colleagues, just an amazing collection of really, really good people, a totally free and open environment. People were there with their doors open. If you had something you needed to ask somebody, there was probably an expert just down the hall, and you could ask him or her what was going on. And there was no pressure for immediate results. I mean, if you read business news, there's a lot of this, well, what have you done for us this week kind of thing. And there was none of that at the labs. And so people were free to work on things that they thought were important and relevant for really extended periods of time without any sort of, well, you haven't done anything much. So, and I think that's partly because management at Bell Labs was pretty enlightened, and they figured it's hard to know what's going to come out of a research activity because by definition you're doing something new, and so they didn't worry about it. They figured that in aggregate they would get good stuff, even though you couldn't predict which particular person on which project was going to pay off in some sense. So from that standpoint, it was just a great place to be. I really enjoyed it, and that's one of the reasons I guess they stuck it out there for 30 odd years or something like that.
Yeah, so I read that during your time there, you were instrumental in the design of Unix, which for the listeners is an operating system that continues to influence the digital world today. And I think I even use it on one of my computers. But how do you see operating systems evolving today? Like, how are they different from back then?
Yeah, well, let me correct a potential misunderstanding there. I didn't actually have anything to do with the design or implementation of Unix. I was in the group that did that, but it was fundamentally the work of two people, Ken Tubbs and Dennis Ritchie. And I was more what you would call a camp follower, or somebody who was there contributing, but not to the core operating system. I did write programs that people used and some that they still use even today, surprisingly. Some tools for document preparation, some things for just helping people write programs. And I actually wrote a fair amount of documentation of one sort or another for how to use the various things that were coming out of Unix. And so that that was kind of my ecological niche, if you like, because other people weren't as interested in writing those things. I don't really track what goes on in operating systems much these days. I mean, I'm just using whatever I've got. I'm sitting here with a Mac, and it's running underneath it what amounts to a version of Unix. So if you're using a Mac, you're using Unix, and and I've done that for a very long time. The computers that the university uses are all running Linux, which is another flavor of Unix, and in fact, that's kind of pervasive everywhere. I guess in the real world, mostly Linux runs on servers. So if you use absolutely any internet service, like we're using Zoom at the moment, that's running on Linux, no question. Um, Most people are running either Windows or Mac OS on personal computers. In universities, most, a large majority have Macs. Windows machines are not as common. I don't know what it's like in a random high school somewhere. I just have no sense of that. And certainly I haven't used Windows for a very long time. So I feel I'm out of it. But it's clear that all operating systems are coping with similar kinds of problems. One is that computers have gotten more powerful, but they got more powerful recently by parallelism, so that there's multiple cores in the CPU, and then there's GPUs to assist with certain kinds of processing as well. And the programs, of course, continue to get bigger. The programs that I might have thought were big 50 years ago are infinitesimal today. And so modern programs are huge. And a lot of that then, and because those computers are connected using the internet, a lot of that leads to security issues. That it's just all too easy for somebody basically to take advantage of some error or a design failing or whatever in a program and use that as leverage to get in and steal or something like that. That's the kind of infrastructure approach, and the whatever you call it, the not so infrastructure approach is stuff like phishing and other attacks on individuals. So, and those are things that operating systems really still today have to worry about, and probably a great deal more, certainly much more than they did in the early days of Unix and other operating systems.
Thank you. So I also know that you've been involved in like the development of several programming languages, such as like AWK and a mathematical programming language. So what concerns did you have to deal with in like making these languages in terms of thinking about like users, hardware demands, and performance in general?
Well, performance in general was clearly a big problem because machines of the time, let's call this, Occ dates from the late 70s, AMPL dates from the early to mid 80s. The machines at the time were incredibly wimpy by today's standards. I mean, they didn't have as much memory and they didn't run anywhere near as fast. And so that meant that you spent more time thinking about efficiency of how do you make something that will run fast enough in constrained space on a slowish processor. And that was good in one sense because it forced you to think about what you were doing, the implementation. You look for generality, you look for efficient algorithms, and so on. But it also often led to really the code that you wouldn't want to write today. Really tricky stuff, and a lot of it was written in C, which has many merits, but has some potential drawbacks as well. It's easy to shoot yourself in the foot with C programs. So all of those things meant that those programs were focused, a certain amount of them was definitely focused on performance. And that's less of a concern today because machines, loosely are getting twice as fast every couple of years now by broadening into more processors, not by just faster processors. So the other thing was that your question hinted at was, how do you figure out what to make for somebody to use? And awk was an experiment in designing a language that would make it easy for people to process text and numbers with equal facility, just similarly easy to work with. And at the time, the language that we were working with was C, which is really, really good for processing certain kinds of things, but it was fine for numbers. It wasn't all that great for processing strings of characters, not in the sense that maybe Python would be today. And it had this compilation cycle where you would have to run something through a compiler and then through a linker to put it all together, and then that would give you an executable program. And so we wanted something that would eliminate as well that kind of overhead so that you could think of just start the thing and run it in the way that you can do, let's say, Python today, because the compilation stage is hidden. And so we built an interpreter, and we also designed a language so that it would be really, really easy to express simple computations as in effect one-liners. So a typical awk program would be one line, it would be two if it was a big one. And so that was a conscious design decision. And we achieved it in part by just, making all kinds of things default sensibly. So you didn't have to declare variables. If you named one, it sprang into existence. And you didn't have to write an input loop that happened automatically. It's just things like that. Um, so, so I think that one's a success. It is still very much alive today. Lots and lots of people using it. I put a new version of it on GitHub yesterday, within living memory. So, where we're continuing to play with that. AMPL, the other one you mentioned, is totally different in a way. It's a language for specifying mathematical optimization problems, like linear programming is the classic vanilla version of that. How do you express an optimization problem in a form that's very natural for users? And again, this is the how do you design for users? In this case, what you're doing is to try and find something that's a pretty decent match for mathematical notation. So if you and I were sitting in a room and we were talking about linear programming, we'd write funny things on the board with subscripts and summation signs, right? And for AMPL, what we tried to do is a notation that would make that as natural a transition into something you could type in ASCII characters. And then that would translate whatever you wrote into basically a giant data structure that would go into a solver program that would do the actual solution of the linear programming thing, and then give you back results, which you could map back into what the user wanted. And so that's still a going concern as well. That was done with Dave Gay and Bob Forer, who were at the labs at the time, Bob on leave from Northwestern University. And eventually we formed a little tiny company to do that, and that company still exists. It's still small, but maybe a dozen employees or something like that. And I'm not really involved in the day-to-day operations at all. But again, it's something that has found users because it seems to be a very effective way to specify optimization problems, and lots of industries have optimization problems that they really want to get the most out of some set of resources. So that's where those two came from.
Yeah, so I'm one of the many people who have read your reference book on the C programming language, and I think I have it somewhere on my bookshelf right now. But I wanted to ask, like, what are some of the considerations that one needs to think about when writing educational materials for something like a new programming language?
I think this is my personal perspective, obviously. I think the critical thing for me has always been to try and find examples that are the right match. You want examples that take somebody from not knowing anything or not very much through to your reasonable mastery of the language. You want examples that are realistic, something that a working programmer might encounter in day-to-day life. I want to do this kind of chore. Okay, and then try to arrange the book so that the example, the explanation, and so on comes in an order, whereas the person starting to think of it, I wonder how you do that. The example is right there, and then they can see the example and they can build off it. And then if the examples are well chosen, people can also use the book, the tutorial, or whatever, go back and say, no, I remember he talked about something or other. Find it in the index. Oh, that's how you do it. And so certainly in the days before things like Stack Overflow or whatever, this is, people actually use books. You remember books? So people use books and manuals and things like that that contain these examples that were meant to be helpful, accurate, authoritative, and models of how to do things well, presented in a sequence that made sense. It's hard work. It really is. So, and so I don't know what else you can do. The other thing is that the world is different in many ways today than it was in those days. Programs were very small when I was doing this kind of programming. 1,000 line, 2,000 line program would be, not big, but typical for many things. And a lot of the early programs that people used were quite small. I mean, the original operating system was less than 10,000 lines, so very, very small by today's standards. And so if you get bigger programs, and especially if you get more than one person working on a program, you need different tools. And so that's where things like IDEs, like say VS Code, which a lot of people like, are very important. Things like Git for keeping track of what's going on, and especially if you've got more than one person working on a big program. And then GitHub to put that all in the net. All of these things are things that weren't really part of the world when we got started, but are increasingly helpful today as more people work on bigger programs from more different places at one time. And so it's, in that sense, the world has changed. I People sometimes ask me what I use as a debugger, and I will just say right up front, keep off my lawn. I use print statements, but, but that marks me as perhaps somewhat antiquated in my approach to life.
Yeah, so changing gears a bit, what advice would you have for high school students who would like to get into computer science?
Well, I mean, the bottom line is go for it. I mean, why not? It's still one of those fields where the barrier to entry is just tiny. I mean, there really isn't any barrier to entry. There's so much material available that will help you learn. There's so many people who are also involved who can lean on, or you can build things with together. Just all of these kinds of things. I mean, if you want to be a microbiologist, it's just harder, right? And so if this stuff interests you, go for it. It doesn't say you have to do it, but I think it's useful. It's enormous fun. It's challenging in many of the right kinds of ways. If you're the kind of person who likes solving intellectual puzzles or playing in systems that have rules that you can eventually figure out, all of these things, it's good. And of course, realistically, you can get a job. I mean, there are lots of interesting things that people do where it's hard to get a good job. And computing is one of those where you can get a good job. Well, I think that's likely to be true for a long time, all of those positive aspects of it. The other thing is you don't have to go into computer science to do this kind of thing. I mean, I don't know whether you're at the stage of looking for what college to go to right now, but um, computer science is the hot field at many schools. It's the largest major at Princeton. And there are other schools which have so many computer science applicants that they have to restrict. Um, they won't let everybody in. They can't, because everybody would be a computer science major. But the thing is that computing stuff is applicable in so many other fields that what you want is, call it a journeyman's knowledge of it. You can use a computer to do your bidding, but it's not the professional thing that you're going to do. You're not going to be a software engineer necessarily, but you could be applying computing in any other field you want and having that same kind of fun, making probably plausibly similar amounts of money, and maybe even finding it easier in some ways because there won't be as many people in it. It won't be as crowded. I mean, if you're the first kid in the block who's applying computers to, I don't know, study of ancient languages or something, that's an easier lift in some ways than trying to build the next operating system. So I'd say there's all kinds of interesting things that you can do, and just be open-minded about it, but also don't get forced into it. And it's maybe the kind of thing where parents say, "Oh, you want to go into computing because," in the same way they might have said you want to be a doctor or a lawyer or something like that, and I want to be a programmer. Do it because you're interested.
Yeah, thank you. So I know that you also recently authored a new version of a book, Understanding the Digital World, What You Need to Know About Computers, the Internet, Privacy and Security. And it like focuses on computing essentials. So how have these key aspects of like our digital world evolved in the last decades?
Yeah, yeah. That book, by the way, is a derivative of the course that we talked about earlier, the one for non-technical people. In some ways, it's take the lectures and transcribe them onto paper. Um, some parts of what's in that course don't change a bit. I mean, binary numbers have been around for a very long time, and how to do arithmetic in different bases has been around for a long time. The digital, how do you represent things digitally? What does that mean? That hasn't changed. The basic algorithms haven't changed very much, and sorting is still sorting. There's all kind. So there's that kind of stuff which doesn't change, and an understanding of sort of how that works. Not that you could necessarily go off and do it right away, but understanding something about like, you can sort this quickly, but not that quickly, or you can have a dumb version or a smart version. All these kinds of things are useful insights that don't change. Um, Things that do change, communications is continues to be more and more important. Internet, obviously, just a pervasive part of our lives. The cell phone, the use of cell phones in the internet is just merged for most people, I think. And certainly we're surrounded by wireless kinds of stuff, uh, ranging from little earbuds to I'm sitting here wirelessly talking to you because I don't want to have to move the power brick, and on and on. So that's important. I think the thing that's changed most radically and is continuing to evolve and is really kind of worrying in a lot of ways is the security and privacy aspects. Uh, and the internet is everywhere, obviously, and so that means that you can contact friends who are far away, and that's great. But bad guys can contact you from far away, and that's not so great. And we have an increasing number of Internet of Things kinds of devices. In many cases, we have welcomed really sophisticated spying machines into our homes. I mean, I won't ask whether you have an Alexa, for example, or an Echo Ring, or sorry, Amazon Ring, or all of these kinds of things that are basically watching you. I don't know what your TV does, but your TV is probably spying on you as well, and on and on and on. Your cell phone is obviously spying on you continuously. And so I think people don't realize just how much of that is going on. And I think that is a worrying thing that I try to talk about in my class to get kids there to be more sensitive to how much they're given away for not much benefit. And something as simple as a class exercise. Okay, open up your laptop, let's count the cookies. And the standard response for that, when I say how many cookies are there, is I can't count them. There's so many because they've got thousands, tens of thousands of cookies, which says somebody, let's call it Facebook or Google or whatever, knows an enormous amount, but probably more than anyone else in the world knows. So, and of course, ubiquitous cameras everywhere, all of these kinds of things. So that's a part of it that I worry about. And then the other thing that is even more recent, perhaps, is systems that use all of that data, artificial intelligence and machine learning systems that use all of that data to know ever more about us. And so I worry about that kind of thing as well. And that's kind of, at this point, unrestricted. Certainly in the United States, it's unrestricted. And so my guess is that somewhere there's a facial recognition system that when you walk into a store, it says, oh, there's Victor again, I wonder. And so that kind of thing is something where I think people ought to be more sensitive to it and more aware of it. And probably we need, let's call it the government, to do something about it, to sort of knock down the power of some of these enormously influential companies like Facebook and Google and Amazon in particular come to mind. So I'm not optimistic, but I think those are things we ought to be thinking about.
Yeah, that's very interesting. So as a final question, where do you think that computer science or computing in general is going to go in the future?
If I could predict the future, I'd be much more financially stable. Right, but this is true of all. Well, some of what we just talked about is part of that, of course. I see something else. You see the fragmentation of the internet as various geopolitical things play out. The Great Firewall of China, Iran cutting down on connectivity for its citizens, and that's true in a lot of different places. So that's an issue. The internet used to be connect everybody, and now you get these little islands, big islands, where the connection is in some way filtered or impeded. Um, the loss of privacy, that's a personal thing for lots of people, but I think there's let's call them cyber risks. Cyber is overused, but there are a lot of risks associated with the increasing use of computers and the communication systems. And you can see good and bad sides of it. The war between Russia and Iran and Ukraine, obviously, where drones are being used on both sides. I mean, that's stuff that's enabled by the technology we're talking about at this point. There are, I think, some really serious downsides to artificial intelligence and machine learning. Those because they're not trained well or because their algorithms are basically unexplainable, they have a strong tendency to discriminate against various populations and can be used actively to discriminate against populations as well. So I think those are all kinds of things where we're not going in the right direction, let's say. On the other hand, I mean, there are some positives. Many things that come out of AI and ML are quite positive. Machine translation is a nice one where you can take something written in more or less any language and get at least a notion of what it's talking about in some other language. You say, oh, that's interesting. I'm getting spam in Chinese, and I don't know any Chinese at all. That happens to me all the time. We are learning how to make better programs. I think our programming is, although a lot of it is cut and paste from Stack Overflow, but we are definitely, I think we take on bigger problems and we get to do interesting things with computings that would have been hard years ago. And that means that there's more useful computing in our lives. I mean, I dump on a lot of these things, like I don't use Facebook and I don't use LinkedIn and I get so on and so on. But those are actually useful for many people. So that's good. Well, I find it's still a fun area to work in. I mean, I complain a lot, but the various ways in which it shows up in my life and how I'm able to use it, that's a lot of fun. Yeah, those are the good things, I guess.
Yeah, thank you very much for meeting with me and for being willing to do this interview.
No, it's my pleasure. It's fun. I hope you were able to do something useful with it.
Yeah, thank you.